Assalamu alaikum warahmatullahi wabarakatuh. Welcome back to my channel on YouTube, Drilling and Workover. This is Abdelaziz Gabr. I am accredited instructor on IWCF Well Control and IEDC Well Sharp, and also I am accredited instructor in IEDC Mod Engineering Basic and Advanced Mod School. Uh, Yesterday we have talked about the pressure gauge readings errors. And today we will go to the last lesson in B and B or practice and principles, and inshallah we will finish it. Then inshallah we will take long rest and start after coming from work with the simulator and with the equipment. So we have talked about the driller method and about the weight and weight method. Today we are talking about new method. It's called concurrent method. Why we use concurrent method or when we use concurrent method? Actually, concurrent method depends on increasing the mud gradually. As you see here, it starts from 12.1 ppg, then increase until to 12.2 ppg. After this, increase to 12.3, 12.4, etc. until killing the well. Here you have to notice that in the concurrent method you are mixing mud while circulating and increasing the mud gradually until until killing the well. You have to keep here. So what is the concurrent method? It's a killing method with more than two or three or four types of four circulation times. In this, it depends on a gradual increase in mud weight from the original mud until to the kill mud weight, and every circulation has its own ICB and its own FCB and its own down pressure schedule. So you have to keep in mind about this issue. The well is completely killed after the last circulation and the pressures are zero in casing and in drill pipe. So that the concurrent method, when we use it when we don't have enough place or capacity of the rig to handle the kill mud and the circulating mud coming out of the well. Because like on offshore, you have a little space and you have to kill the well so that you make a concurrent method. Also, concurrent method is used after killing the well, for example, with kill mud weight with weight and weight method, but the kill mud weight is not enough to kill the well, so you can go with the concurrent method to increase the mud gradually, because if you increase it suddenly it may make problem and something like that. So the concurrent method is very easy and simple, and it is not common used in the drilling. Also, there is something is called volumetric method. This is the fourth type. Volumetric method is the fourth type. What about the volumetric method? It doesn't kill the well. It is not killing the well, but it is a way to exclude the influx from the well by making gas migration, or by making migration of gas inside the casing and exclude it out from the well. Uh, it's also a way to it has the most important condition is to keep bottom hole constant as before, and also you have to pay attention to the mass to the mass while migrating of the gas in the anus. It depends on Boyle's law. B1 V1 equal B2 V2, so that you have to keep in mind about this issue, and we will talk about it when we use volumetric method. Volumetric method is used when you cannot make circulation, or when you cannot make easily circulation, or when you cannot use the driller method or weight and weight method. So here the volumetric is used, so that uh, bit on the bottom is plugged, so you cannot make circulation, is plugged. Okay. uh, Failure in float valve and drill pipe pressure, and it has been failed, so you cannot pump from it, so also it is plugged. Number three, the bit is off bottom and not possible to strip or pipe to strip the drill pipe inside it, or the pipe is stuck. So this is non-routine situation to use the driller method or the wet and wait method. So at this time we go directly to the volumetric method. Also, if the drill string is out of hole, so you cannot make it. Okay, if there is wash out in the drill string, so that the method used of the volumetric method is used when you cannot use neither the driller method or uh, nor the what's it called, the wet and wait method now, and also for the failure of the mud pump. And all of these are questions in IWCF, so you have to pay attention to it. How can we use the volumetric method to get rid of the gas while migration? Look here, once you have here the gas, assume that here the drill string is plugged and you get here a gas influx, and its pressure here is 520 and here 820. Okay, and the bottom hole pressure is 70 psi. So we need to keep the bottom hole pressure to be constant, so that in order not to take second kick, so we let the pressure for the bottom hole pressure to be more than to be overbalanced by 100 psi over it. Why? In order not to have some wrong while bleed the pressure, so that you can take second kick. No, we make 100 psi over the bottom hole pressure, like here. Okay, 100 psi is more to keep the bottom hole pressure constant. And and after this we stop and monitor the casing pressure. What we are monitoring, we monitor the casing pressure. Okay, so that if there is migration of gas, as you see, the increasing in casing pressure will be increase the there will be increase in casing pressure more than any other pressure, yeah. Okay, so there will be increasing in casing pressure. And as I told you here, the drill pipe pressure will be stay the same. Why? Because here there is no communication between the drill string and the annulus, so we keep the drill pipe pressure at a value, and if it increases than it, we have to make bleed until the required pressure to be above the bottom hole by 100 psi, and make bleed, then another bleed. So once you make bleed, the volume of the gas increases. As you see, the volume of the gas increases until it reach to the maximum at the surface. So you have to make bleed and keep your eye on it, once you finish bleeding the pressure and keeping the casing pressure to be overbalanced, to be the bottom hole pressure to be overbalanced by 100 psi. At this time you can make fill of the from the kill line. You can make fill for the kill mud by using the kill line. And at this time it's called lubricate, bleed and lubricate. It's called lubricate and bleed. So the volumetric method application, as I told, bleed and lubricate. We record at first the shutting casing pressure at first time, and monitor the increase in shutting casing pressure due to gas migration. Then bleed the pressure, so keep the pressure 100 psi more than shutting casing pressure, which means 100 psi more than the bottom hole pressure. Then we add mud gradually from kill line after get rid of the influx. Another issue, it's called stripping. What is the meaning of stripping? Stripping means once you pull out falls, for example, 10 stand, 30 stand, something like this, and you get kick, so the kick is below the string. So you have to run in hole again with the drill pipe until reach to the bottom and make circulation or start killing the well again. But how you make this? If you run in hole, here the BOB annular, here the BOB annular, and I will talk with you about the stripping inshallah in the equipment. And you have to know that the stripping can be done with the annular, and also it can be done with at least two fixed rams or with the annular. For example, if we use here, if the annular heel is shot in the well, makes shot in the well, so there is here a pressure in the drill pipe and a pressure in the casing pressure. Okay, so if how can you run in hole? You cannot run in hole. You cannot run in hole with this type because there is a pressure from below. So what we do, we add some sub. It's called the full opening safety valve is put here, okay, and then closed. Okay, you put the full opening safety valve closed, okay, and close it. Then you add or you put something is called IBOB or internal BOB or back pressure valve. It is the same meaning. Then we open the full opening safety valve below it. Okay, so now we make secure to the drill pipe and we run in hole with it slowly. So once you run stand, here the volume uh, is decreased, okay, and so that the pressure of the mud increase, which means that if it increases more than a value, it may make fracture to the formation. So we make bleed from here. How we bleed? Take care, because this is very important question in the IWCF. While stripping, it is volume balance. It is not pressure balance, but it is volume balance. So once you run in hole here, all the volume of the closed end tubing or closed end drill pipe here is compensated by or is bleeded. So for example, if one stand equal to for example half barrel, so once you run one stand here or two stands here with half barrel, you have to bleed after two stand, you have to bleed one barrel through that choke line. And after this, run another stand, another two stands, and bleed two barrels, and let's see, and vice versa, and everything is okay. Okay, so this is very important method. As I told you, stripping is emergency well controlled procedure, and it is used when the pipe weight is sufficient to overcome the upward force created by the pressure. Pressure control is based on volume balance. Volume balance. Take care of this word because it is very important. Volume balance, as it is necessary to install an inside BOB, but to install IBOB, you have to put at first full opening safety valve, and we will take the difference between full opening safety valve and inside BOB when we are dealing with the equipment, inshallah. From the annulus, we bleed the same amount of closed end capacity every stand to keep the bottom hole pressure to be constant as V1 equal V2, so that if we bleed the same volume, so the pressure will be the same. Bullheading. What is the meaning of bullheading? Bullheading is mainly in the workover. It means that once you are producing or something like this, there is here formation fluids from the formation coming from the tubing, and you need to kill it. So you bump the kill mud, or you bump the kill mud weight or the brine or something like this, and force the hydrocarbons or the formation fluids to come again inside the formation. And you must know the maximum surface pressure of bullheading, and it has to be discussed with the engineering or with the team leader or something like this. Also, the volume is how about the volume pumped? The volume is pumped with the total string plus the distance or the annulus from the mid of the birth until the last point in the drill string. So this is very important method. Volume to be pumped equal to the tubing string plus volume of the area below the backer. Now there is some problems. There are some problems during the well control operation. What are the common well control problems? Blockage. Blockage in the string, blockage in the annulus, blockage in the choke. All this may happen while killing the well. So you have to be ready for any of the situations. Also, maybe also washout in string or in choke or by BOB rams or anything like this. So in order to see if there is washout in the BOB rams, there is very nice question coming to you in the exam. Why we keep monitoring the trip tank while circulating a kick through the choke? Okay, through the choke, you don't even monitor the trip tank, but we make monitoring. Why? Because if the seal of the BOB has a problem, or if the seal has failed, or if the BOB has made washout, you can notice and go to the second step directly to close another barrier of the BOB. Surface equipment failure also may happen losses and hydrates. Here, hydrates, it's very important point to be mentioned. And what are the reason for hydrates? Actually, fresh water vapor, I think again, fresh water vapor, plus the gases in high pressure and low temperature. High temperature and low temperature with fresh water can lead to the formation of hydrates. And to remove the hydrates, you have to inject methanol or glycol. Methanol or glycol. These are two questions for the hydrates. What are the main problems? If you take loss of circulation, what will happen to the drill pipe pressure and the casing pressure and the bottom hole? Actually, both of them will decrease suddenly. So you take loss of circulation and the bottom hole pressure will decrease also. If the choke has plugged due to the cuttings or something like this, which comes to the choke, what will happen? First of all, you will see that the casing pressure will increase, then followed by increase in drill pipe, and the total bottom hole pressure will increase. What about the choke washout? If the choke washout, you will see sudden decrease in casing, then sudden decrease in drill pipe pressure, and the total bottom hole pressure will be decreased. What about the plugged nozzles? If a nozzle plugged, you will see directly sudden increase in the drill pipe, but the casing pressure will remain the same, and the bottom hole pressure will be the same. So there is very important question here. While, for example, while killing the well, the ICB increases suddenly from 1000 to 1000 and 1000 or 1100, for example, from 1000 to 1100. So only 100 psi increased. So what you do? Okay, continue drilling, continue killing. Okay, you have to shut down the pump and discuss the problem. And once you get the problem, it is nozzle plugged. You have to continue drilling with the new ICB, with the new ICB you have made, and to check about the final FCB also, and to continue drilling without any problem, because bottom hole pressure is controlled through the casing and no problem. What about the nozzle washout? Nozzle washout is the same. You will see decrease in drill pipe pressure, but also the casing pressure will be the same without any change, and bottom hole pressure will be the same without any change. Pump failure, you will see that the drill pipe pressure will decrease, then the casing pressure will decrease also suddenly, and the bottom hole pressure totally. Uh, at this time, we have to keep constant. We have to keep constant while pump failure, for example, you have to keep constant for the casing and keep the bottom hole pressure to be the same. Annulus backoff. Annulus backoff. At this type, you will see that there is sudden increase in drill pipe pressure, but the casing pressure reads zero. Reads zero, and bottom hole pressure for sure. If you increased the drill pipe pressure, it will increase, but in this case, it will be the same. Well control problems. For any well control problem, some procedures must be taken. And what are these procedures? Stop killing the well, shut down the pump, or shut in the well. Stop killing the well by shut down the pump, keeping casing pressure to be constant. Shut in the well, then discuss what is the problem, then analyze the problem or evaluate the situation. There is some bad practices. What are the bad practices that may lead to another problem in well control? First, incorrect startup. Incorrect startup means that while startup, while instead of keeping casing pressure to be constant, but you make the drill pipe pressure to be constant. At this way, you will make a problem and you may get second kick. Also, changing stroke per minute while killing. Changing stroke per minute, you have while changing the stroke per minute, you have to keep the casing pressure to be constant, last casing pressure to be constant, and at this time you have to you can change stroke per minute without any problem. Holding wrong pressure, as I told you before, not following the graph or step down in weight and weight method. Not pumping correct mud weight. Also, this is a bad calculation or bad practice. How you get bottom hole pressure constant and correct. First one, to use the correct startup from zero rate to kill rate, keeping the casing pressure to be constant. Maintain correct stroke per minute. To maintain correct stroke per minute. Number three, correct pressure versus the number of strokes, especially in weight and weight method. Number four, correct mud weight. Now we will go to some bad practices, inshallah, and we will finish it quickly. The procedure, bringing up pump to the kill speed. So the best here, our correct action is to keep casing pressure to be constant. Keeping casing pressure to be constant. But what is the wrong action? The wrong action is to keep the drill pipe pressure to be constant. So if you kept the drill pipe pressure to be constant, actually while you are starting pump from zero to kill rate, the drill pipe pressure will increase until it reaches to from shut-in drill pipe pressure to reach to the ICP. So if you keep the shut-in drill pipe pressure to be constant, this means you have to open that choke, and at this time you will decrease the bottom hole pressure and get second kick. So you make decrease in bottom hole pressure and you will get second kick. Number two, for bad procedures or bad practices, in the driller method for the first circulation. First circulation in the driller method. What is the correct action? In the first circulation, as I told you, you keep shut in drill pipe pressure or you keep drill pipe pressure to be constant at the ICP. So here, keep drill pipe pressure to be constant ICP. What is the wrong? Is to keep the annulus to be constant or the casing pressure to be constant. So if you kept the casing pressure to be constant while it is increasing, so you will open the choke. This means that the bottom hole pressure will decrease also and you will get second kick. Number three, what the driller method, second circulation while pumping kill mud from surface to the bed. At this type, you have to keep the casing pressure to be constant. The correct action is to keep casing pressure to be constant. But what is the wrong? Is to keep the drill pipe pressure constant. So if you kept the drill pipe pressure to be constant while second circulation, if you pump kill mud weight, so the drill pipe pressure will decrease. The drill pipe pressure will decrease from ICB to the FCB. Okay, so that if you keep it constant, so this means you are closing the choke more. This means that the bottom hole pressure will increase and you may exceed the base and go to the fracture of the formation. For bad practice also, what about the driller method? Second circulation while pump kill mud from the bed to the surface. As I told you at this time, the one phase is in the drill string, so you have to keep the drill pipe pressure to be constant at the FCB. This is the right answer. Keep drill pipe pressure to be constant at the FCB. So what is the wrong? Wrong action is to keep casing pressure to be constant. The casing pressure to be constant, the casing pressure while pumping kill mud from the pit to the surface, it decreases. It decreases. So if you keep it constant, this means you are closing the choke more than the required, and at this time you are increasing the bottom hole pressure and it may exceed the max. For the weight and weight while pumping kill mud to the bed. Here you are following as a correct action. You are following the schedule or step down, the step down pressure schedule. Okay, from ICB to the FCB. Okay, so it decreases. The drill pipe pressure decrease. So what is the wrong action is to keep the drill pipe pressure constant. To keep the drill pipe pressure constant, this means that you are in closing the choke more to keep the ICB. This means that it will increase the bottom hole pressure and it may exceed the mast. Also, what about the weight and weight bumping kill mud from the bed to the surface? This is the same. This is the same like in the we have talked in the drill in the with air driller method. Uh, you have to keep the drill pipe pressure to be constant at the FCB. You have to keep drill pipe pressure constant at FCB. But what is the wrong is to keep casing to be constant. Or what about casing? Casing is increasing but with little value than before. So it's increasing. So once you keep casing constant, this means you are opening the choke, and at this time you will make decrease in bottom hole pressure and you may get second kick. Increasing pump speed, increasing pump speed or new stroke per minute. So it makes a new ICB and new FCB. This is the procedure. So the correct action while increasing pump, decreasing pump, anything about the pump change, you have to keep casing pressure or the last casing pressure to be constant. So keep casing pressure to be constant. What is the wrong? The wrong is to keep drill pipe pressure constant. So what is the effect on bottom hole? Here, if you increase the pump speed, so the pressure in the drill string will increase. So what is the effect? What is will increase? So if you keep the drill pipe pressure to be constant, so you will open the choke more than the required. So this means that you will make decrease in pump pressure, decrease in the bottom hole pressure, and you will get second kick. What about also if you decrease the pump speed? Decrease the pump speed with new ICB and new FCB. But again, the same. Correct. What is the correct action? The correct action here is to keep casing pressure also to be constant. Keep casing pressure to be constant. What is the wrong action to keep the drill pipe pressure to be constant? But what about the behavior of drill pipe pressure if you decrease the pump speed? If you decrease pump speed, the drill pipe pressure will keep decreasing. So if you kept it constant, this means that you are closing the choke more than the required. This means that you will increase the bottom hole pressure and you may exceed the max. I think that for the end of the bottom hole pressure, although this is not important point, at the end of this course, really I am very happy that we have talked about the B&B and we have finished it, inshallah. Inshallah, bismillah, we will talk long rest plus or minus 10 days or 14 days until I came again from the rig, and I will start with the simulator. Then I will take the equipment, will control equipment, the BOB, the annular, the rams, the accumulator, the com unit, all of this issue I will talk about. So keep tuned, please. If you have any point not clear for you, please you can ask me. If this video appeals to you, share